Hey everyone, my name is Sandeep, and I'm a developer advocate at Google. Today, I'll be bringing you some quick tips to get started with Google Compute Engine. Setting up your Google Cloud Platform account. Before we jump into doing things, let's set up your account. If you already have one, you can just skip forward. The first thing you need is a Google account. If you use Gmail, Google+, YouTube, or Android, you already have one of these. When you sign up for the trial, it'll ask you for credit card information. But we won't charge you unless you upgrade your account. And don't worry about your code. We automatically pause your account after the free trial is over, so you can upgrade when you're ready. You can see the free trial page for more information. Using the Cloud Launcher to quickly deploy WordPress. So you want to get your website up and running fast. The best way to do this is to use the Cloud Launcher. Here, you can select pre-configured images and launch them in just a few clicks. Let's go to cloud.google.com to get started. Make sure you are logged in to your Google account. If you can see your picture and the My Console link, you're good to go. Now click the launcher link. Welcome to the Cloud Launcher. The launcher has hundreds of pre-configured images from Google and partners such as Bitnami that you can launch with just a few clicks. In our case, we want to start a WordPress website, so we click on the WordPress Google Click to Deploy solution. Here, we can see typical cost for this solution and what is included. By default, it launches an N1 standard 1 machine with an additional 100 gigabytes of disk, and the estimated monthly cost is around $35.84. Using the pricing calculator to estimate pricing. Before we keep going, I'm going to show you how you can customize your estimate by using the pricing calculator. While the free trial makes it easy to experiment until you find your perfect solution, it's a good idea to use the pricing calculator to estimate your costs. This way, you can create a combination that works for you. On cloud.google.com, click the pricing link. Then, click on Get a Custom Quote. Here, you can play with different configurations to get the setup that fits your budget and needs. For this example, I'm going to be hosting a small website. So I have one server, and I select a free operating system, and a G1 small instance type. This server is going to be running all day and all night, so these numbers look good. So I'll select the G1 small instance with 50 gigabytes of disk space. The monthly cost comes to around $18.35. This looks great, but remember, it is only an estimate and your actual cost can vary. Now that we've found the image we want to deploy and the estimated costs, it's time to deploy it. Let's go back to the Cloud Launcher and select the WordPress image. The first thing we want to do is click Get Started. Now, select the project you want to deploy into, or create a new one. I've already created one for this example, so I'm going to select that one. Now we see the configuration page. For the Google Click to Deploy solutions, the configuration section will be customized for that particular solution. For WordPress, the options are rather straightforward. I can change my zone if I want. Then, I select the G1 small instance, like I configured in the pricing section, and set the disk to 50 gigabytes. Then, I type in my admin email. I also make sure that phpMyAdmin is checked. Once I click Deploy WordPress, the wheels start turning. As you can see, deployment can take around 4 to 5 minutes to complete, so I'm going to fast forward this section. After a few minutes, we can see our WordPress instance is up and running. Configuring firewalls and networks. Now that the instance is running, I'm going to show you how to access it. The first step is to configure the firewall to allow HTTP traffic. Go to cloud.google.com, then select the My Console link. Select the project you're working on. Click Compute, Compute Engine, and VM Instances. Click the external IP and check Enable HTTP option. If you want to make some more complex rules, we had to visit the network section. Click Network on the side panel, then select the network you want to modify. In most cases, you just need to modify the default network. Here, we can see all the rules for the whole default network. You may notice that HTTP rule we made is not here, and that is because that rule is only for the specific machine. If you want all machines on the default network to expose port 80, this is the best place to do it. So let's add a firewall rule, and then call the rule HTTP. Then type 0.0.0.0/0 to allow anyone to access our website, and open up TCP port 80, which is the standard HTTP port. Click Create. Now, all machines on the default network have port 80 open. To delete a click-to-deploy deployment, go to your developer console, go to the Manage section, and then go to Deployments. Click the trash icon to delete the deployment. While click to deploy is awesome and includes a lot of pre-built stacks like mean, lamp, rails, and all the Bitnami images, sometimes you want to roll your own custom setup. Google Cloud Platform makes this easy to do. Before we go any further, I want to mention that Google Cloud has an awesome command line interface and a REST interface that you can use to create, deploy, and manage pretty much anything on the platform, from VMs to storage to databases. You can see how this can make automation really easy. For this video, I'll be doing mostly everything from the GUI, but you might notice little equivalent REST and command line links down below. So everything I'm doing can be replicated via REST on command line as well. The first thing I'm going to do is go to my console. Then I'll go to the compute section and the VM instances section. Now click Create Instance. Here, we can see the config page, and we can give our instance a name and choose a zone. It's a good idea to choose a zone that's close to your customers. Then we can pick a machine type. Pick the right machine type for your workload. I'm going to pick an N1 standard one to start with. Now we choose the boot image and disk. You can see all the options we offer, from Debian to Windows Server to Enterprise Red Hat Linux. You can even create your own image or use a previous snapshot. I like Ubuntu 14.04 LTS, so that's what I'm going to use. I also want it to use an SSD disk, which is much faster, although slightly more expensive. We can also open the HTTP and HTTPS ports right here, saving us a trip to the network section. At this point, we can create our VM, but I want to talk about the advanced optional settings. If we had a fleet of machines, we can give each one individual tags to categorize them. You can also specify a startup script that will run on boot. I like to set up a script that installs Docker and automatically pulls and starts my containers without having me to type anything. In the disk section, you can add additional disks to your machine. I highly recommend creating a disk for storing application data and not storing your application data on the boot disk. In the network section, you can choose if you want a temporary IP address or a static IP address. The temporary address will change every time you reboot your machine, while the static address stays the same and you can actually move it between instances. I like the static addresses because it makes configuring DNS and upgrading machine types that much easier. Note, you will be charged for unused static addresses, so make sure you use them if you make them. In the Access and Security section, you can add SSH keys and enable access to other Google Cloud Platform APIs by default. Now, let's hit Create, and we can see it chugging away in the background. In a few seconds, and I'm serious, the VM is up and running. We can SSH into our box by clicking the little SSH button. If we launched a Windows server, we would get an RDP option instead. You can also download an SSH key to use, or if you've installed the Google Cloud SDK that I previously mentioned, you can SSH directly from there as well. Now, you can do anything you want with your VM. Backups, increasing disk capacity, and upgrading servers. Now that your server is up and running and getting popular, it's important to know how to back up your VM and upgrade it. Thankfully, Google Compute Engine makes it easy. To make a backup of your disk, all you need to do is go to the Snapshot section. Click Create Snapshot, select the disk, and bam! After a few seconds, a snapshot is created. And using the REST or command line interface, you can easily automate this process. You can use this snapshot to create new virtual machines or use it to restore your server to a previous state. Now, let's look at how we can upgrade a machine. I want to do 4 things. 1. Attach a new 100 GB disk for application data. 2. Grow this new disk to 500 GB. 3. Grow my boot disk from 10 GB to 50 GB. And 4. Go from a 1-core machine to a 4-core machine. 1. Attach a new disk to a running instance. Let's look at how we can attach a new blank disk to a running instance. Click the instance you want to attach the disk to. Then, go to the disk section and select New Disk. Let's set it to use an empty image with 100 GB of space. Now that the disk is physically attached to the VM, we need to mount it. For the rest of the tutorial, I'm going to be running Linux commands on an Ubuntu system. These commands should work for most Linux systems, but your particular machine might be a little different. SSH into the machine by clicking the SSH button. Then, let's look at all the disks using the lsblock command. Here, we can see our boot disk, SDA1, is mounted as the root directory. We can also see a new disk called SDB, and there's no mount point. Let's fix that. First, make a new directory to mount our disk. Let's call it mount appdata. Run sudo make dir mount appdata to make our new directory. Then, Google Cloud Platform provides a script to automatically format the disk and mount it. Run this command, which will format and mount the disk. If the disk was pre-formatted, we could use the standard mount command here. Once that is done, we can run lsblock and see the disk is mounted. 2. Increase the size of an attached data disk. Let's say you want to increase the application disk size from 100 GB to 500 GB because your data is growing. The first thing you want to do is stop your server. This will try to perform a clean shutdown so you don't lose any data that might be written to the disk. Then, create a snapshot of the disk. After this is done, go to the disk section and create a new disk. It is very important that you create this new disk in the same zone as the VM. Select the snapshot we just created and set the size to 500 GB. Now, let's go to the Instances screen, click our server, remove the old disk from the instance, and attach the new one. Now, if you boot up your machine, we can run the lsblock command, and the disk is there. We can mount it using the following mount command. And if you run the df-h command, you can see the disk space has not increased. it still says 100 gigabytes. This is because the snapshot we used is set to the old disk size. We need to resize the partition to use the full 500 gigabytes. First, unmount the drive with sudo umount mount app data. While you technically can resize a drive that's currently mounted, it is safer to unmount the drive. Run sudo e2fsck-f and the name of the drive, sdb, then run sudo resize2fs and the name of the drive, again sdb. After that is done, run the mount command again to remount your drive. Now, you can see we get the full 500 gigabytes of disk, and it only took 4 commands. Easy. Resize the boot disk and upgrade your machine type. In order to upgrade your boot disk or upgrade your VM, you need to follow basically the same process. This process requires you to create a brand new instance and delete the old one. First, make sure your VM is stopped. Then, create a snapshot of the boot disk. Then create a new disk using the snapshot. Make sure the zone and size are correct. Now, we need to delete the old instance. Double check that the snapshot and disk are created because deletion is permanent. After this is done, we need to create a new instance to use this new disk. Let's select a 4-core machine and use the new disk we just created. Remember to attach the old data disk as well. Once the machine is created, we need to reuse our old static IP address so we don't have to reconfigure any DNS settings. Go to the network section and select the static IP address. If you're using Ubuntu, Debian, or Windows, the boot disk automatically grows to fill in the new space. At the time I'm recording this video, if you're using another operating system, you will have to resize the partition yourself. Now, let's remount the data drive. Now we have a 4-core machine to handle the higher workload and a bigger boot drive. Turning off the lights. Now you know how to create, backup, and upgrade your machines. Let's take a look at how to delete stuff. This way, you won't be charged for unused resources. First, let's look at the instances page. Here, we can see all running and stopped VMs. A good technique is to stop your VMs that you're not currently using, but want to use in the future. This is like shutting down your PC. While you're not charged for stopped VMs, remember that you are still paying for the disk. If you want to completely remove the VM, use the delete function. By default, this will remove the VM and the boot disk. This action is permanent, so if you want to be safe, make a snapshot of your disk before deleting. Now, let's see how we can remove old disks and snapshots. If we go to the disk section, we can see all the disks. You may notice I can't delete disks that are currently attached to a machine. Disks that are not attached can be deleted by selecting the disk and clicking delete. Some disks, like boot disks, cannot be unattached. The only way to delete these disks is to delete the VM as well. Snapshots are easy to delete as well. Just select the snapshot and hit delete. I hope you enjoyed this quick tutorial on getting started with Google Compute Engine. I can't wait to see what you build.